Good morning, Giselle. Okay, Jeremiah, good to see you. Testy. Okay, we're good. Okay, let's have a word of prayer. We'll get started. Shh. Let's pray. Lord, we thank you for today. Thank you for the weekend that we've had. The nice weather that we had through the weekend. Help us as we get into this week and as we have excitement for to be off next week for the midwinter break, but help us to stay focused on the tasks that are before us here this week. Direct us in this hour. Bless us in thy precious name. Amen. Good to see you, Lacey. I'm waiting for two more to come on, then I've got to make an announcement. I want to just make sure everybody hears. Okay? So, okay, let's get into chapter 6 or lesson 16 today. Okay. In companions, wrong attitudes and wrong actions. So we're going to take the wrong actions. Taking, okay, going back, in companions with wrong attitudes and wrong actions. Going where the ungodly go. Shh. Okay. Gabby, what's going on? What are you guys doing back there? When is it? When do you close? What? Do not, if I have to stop one more time, okay? Then you'll split it up. Okay, going where the ungodly go. Proverbs 1:15 says, "My son, walk not thou in the way in with them, refrain thy foot from their path." Proverbs 23:20 states, "Be not among winebibbers, among riotous eaters of the flesh." 1 Corinthians 15:33, "Be not deceived, evil communication corrupts good manners," or good morals, we could even put it in there. Okay? So what wrong action does God forbid in these three passages? Being among the wrong companions, as our title of our lesson states. Being in the companion, or being among them. Okay? What page is this on, Jesse? 136 deals if you aren't there. Anybody else in the classroom? 136. Class, don't let me forget, I've got a note here, but sometimes I overlook them. Don't let me forget to make an announcement before Bible's over. Like I said, I'm waiting for Adam and Uvia to come online. And then, because I want everybody to hear it, so I don't have to. There's Uvia. Good. One more to go. One down. Good to see you, Uvia. Okay. We're on page 136 of your book, as you've just tuned in. So what does walk in the way indicate? Give me a feedback. See if you where or what does walk in the way in the way do or indicate? Going where they go. Right. They're going where they're going. Okay. Simple answer. Okay. I don't know if I made it more difficult, but I think you're reading more into the question than what was there. And I do that all the time too. That's why I don't like driver's license tests. I don't like any type of test as a teacher because I always read too much into the questions and start speculating about different things and you know I so anyway, that's me. Okay. Would it help you? Would it help you if I sang the notes? I mean, they say that putting words into music or just putting something into it helps you to remember them easier. So would it help you to remember what's up there if I sing it? And all the DAs are saying, or DLs are saying, no, 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 no. Yeah, I need a guitar though, see? I can't play the guitar, so I'll. Okay. So, shh, Doug. Walking the way just says going where they're going. Okay? So, this is the first step to sure defeat. Shh. I'm close, girls. I'm close. I'm close. I'm being generous right now. So, when we go where the world crowd congregates, we automatically place ourselves face to face with the temptations. Okay? You can't go to those places unless you are just so spiritual that nothing tempts you and you never fall into temptation. Okay? You can't place yourself into those situations if and not come out of it scathed in some way. You just can't. Gentlemen? So we move ourselves away from the places where we can see and learn of God. Okay? Is that putting you on a higher pedestal than your friends? What do you think? Is moving away from what they're doing because you want to be with them. Nothing wrong with that necessarily. Okay? You want to help them, and definitely nothing wrong with that. They want to do something, and you say, no, I can't do it. I can't do it for, several reasons. Is that putting you on a higher pedestal than your friends? Hmm? Or saying you don't want to do what they're doing? Okay? Good. A lot of times, though, people put you on a higher pedestal because of that. Okay? You're not putting yourself, but other people are putting you there because they're calling you that goody two-shoe. Oh, you don't want to do this because you are, okay, yeah, okay, or whatever, okay? So, don't be afraid to say no. Many people get in trouble because they begin hanging out wherever the world's crowds hang out in their area. Many students get in trouble because they start hanging around with someone that they know they shouldn't be hanging around with. Okay? Derek, no more with Doug. Okay? Well, see, he's new this year, so giving him benefit of the doubt. Okay. Now, so 1 Corinthians, we've read this. 1 Corinthians 15:33. Be not deceived, evil communication corrupts good manners. So what effect will the world's crowd and hangout have upon a person? Temptations, and it's going to corrupt the morals, good morals. It's going to corrupt your morals. Okay? There's no doubt about that. You can take that information and take it to the bank and deposit it, because it's going to be a fact. Okay? John 3:19-21 states, and this is the condemnation that light is come into the world, and men love darkness rather than light, because their deeds were evil. Stop right there. Do you ever, this is just a sidebar on this, if you listen to the news at any time, if you hear about robberies or break-ins or killings, or murders, let's just put it that way, murders. Generally, when do those things happen? At night. Generally between 6 or 12 and 6 o'clock. Okay? Because those that are doing those evil acts know that they're not probably going to get caught right away in the act, because everyone's asleep. Everyone's at home. Okay? When we have the break-ins around here, they happen at night. Or generally, a lot of times, early morning before things start kicking into the progress. So, because the world, men love darkness rather than light. Okay? For everyone that doeth evil hateth the light, neither cometh to the light, lest his deeds should be reproved. And that's why they don't come to the light, because they don't want to be corrected on what they're doing. But he that doeth truth cometh to the light, that his deeds not may be made known, but that his deeds are wrought with God. They're getting right with God. God is telling you that what you're doing is wrong. And if you are looking to the light, then you are accepting what God is saying to you. So, in your own words, and I have something down, but let's see what you come up with. In your own words, tell why you are not likely to grow in your knowledge of God if you are spending time with the ungodly. Get some feedback. Okay? Questions on the board, or the statements on the board or the screen? Read it. Give me some feedback. DLs, I'm waiting for a response from the class. I know you have some, but I got something here, so if you want to wait till I put mine up, then that's fine. But or if you put some down, that's fine too. Any opinions? Any thoughts? Hold on. Sophia? Okay. So, because they're making fun of you, you're not going to get into the Word of God? Is that what you're saying? Okay. Lena? What was your thoughts? So it's going to pull you away from wanting to get into God's Word or getting to know God, right? Okay. Okay. And yeah. Okay. Okay. Good. Good thoughts. Now, you brought up Doug, Lena. You brought up Six Flags. Okay, that's good. Okay. So we all like the amusement park. Okay. Now, how much time do you spend waiting for the ride? Shh. Hey, how much time do you spend waiting for to get on the ride? Half hour? Half hour? Mint, roughly. Okay. Now, here's a thought, Doug. Here's a thought. Here's the thought. I think you probably know where I'm going with this. They do make pocket Bibles, pocket-sized Bibles. Okay? And you can, while you're in, while you're in line, and I'm not trying to make fun of this, but while you're in line, take out the Bible and read it while you're standing in line. Okay? Okay? You can. Okay. Now, that's just a suggestion. Okay? Here it is. Okay. Here's what, that's enough. Here's what my book came up with for this. The ungodly do not want the light of God shining on them and revealing their sins. Therefore, they do not go to places or do things that would help them to see or learn God. Because you're with them, because as you've said, they're going to intimidate you, they're going to make fun of you, okay? So because they're making fun of you, you don't want to go through that process with them, okay? And so you shy away from God. You shy away from knowing God, learning about God, being in the Word of God. And I made a little light about the Six Flags, and but why not spend some time in God or with God instead of the ungodly? Okay? Shh. Just a few more here. Wavering before the wicked. Okay. Give you a little bit more time to write that if you want to write the whole thing. Okay, while we're in this lull, I'm not sure if Adam's coming on today or not. Okay, for Bible. But here was that announcement. Okay, starting this Wednesday, we're going to have chapel. Okay, and yeah, almost. Okay, hold on. DLs. What I was told this morning is that just be ready for it. More information will be coming out to you of how you can link on to the chapel service. Um, but I have no idea how this all works, but it probably won't be through this link. Okay, we'll get that to you hopefully by tomorrow. Okay, and Mr. S is working on that today. Okay, so anyway, chapel on Wednesday. Okay, chapel on Wednesday. And therefore, this is why everybody in the class here, when the first bell rings out there, you guys need to start becoming in. Okay, I forgot that they rang the first bell out there. But when that first bell rings at 25 after, you need to come in, and then everybody starts heading to the chapel at that time too, okay? So, that was my announcement. Be ready for that on Wednesday, and tune in appropriately however you need to click on the link, okay? We'll let you know. Okay, you know, we're right here in changing categories. So we were talking about going where the ungodly go. This could be just a good spot to quit instead of getting into it and have to finish it later. But anyway, so DLs, gonna gonna call it quits for a few minutes early. Um, Tune in 3 hours and we'll talk about energy and motion, electricity, the force, okay? And we'll see if we can gain some more insight or get electrified. We'll see you later.
Gabby says at this point, I'm just going to get a 0. I don't care, but clearly she cares. All right, guys, page 136, or 137, sorry. 137.
I actually read it for the first time.
Good. So if you read it, then you should be fine. Okay, 137. 137. 137. Okay. If you guys close your literature books, I will give you time before the quiz to look at it. But make sure everyone is on page 137. It has to be everybody, though. Everyone needs to close their literature books. Adrian, in order for that to be for the class. Austin. Otherwise, I'm not going to give you any time at all. You really think putting it in your lap is going to fool me? Thank you. Okay. Okay. Infinitive phrases as nouns. Okay, so we talked about different kinds of verbals. Too bad that wasn't in the game on Friday.
We're not talking about the game on Friday.
All right. Infinitive phrases as nouns. Okay, so we talked about different kinds of verbals. We were just talking about, guys. We were just talking about gerunds used as nouns. Obviously, gerunds are always used as nouns. But let's look at infinitive phrases. What do infinitive phrases have? The word to plus what, class? A verb. Okay, so to run, to walk, to see, to sing. Okay, all of those are infinitive phrases. So now we're going to see how they're used as subjects. We're going to see how they're used as direct objects, kind of like what we just saw with gerund phrases. Okay, look at number 1. An infinitive an infinitive is a verb form used as a noun, adjective, or adverb. Okay, like nouns, infinitives can be used as subjects. They can be used as direct objects, predicate nominatives, objects of the prepositions, and appositives. Okay, the infinitive usually is preceded by the word to. Okay, so to hear her play the piano is always a pleasure. My verb is. Shh, guys, please stop talking. To hear her play the piano is my whole infinitive phrase, used as the subject. Okay, here it is used as the direct object. They like, they is my subject, like is my verb. What do they like? To shop in Atlanta. That is my direct object. Okay, Adrian, why are you sitting like that? Are you and Isaac fighting? Is that why you're sitting like that?
You make it sound like I
Well, can you please sit properly or move to the desk next to you if you're gonna, just not in the, here. Thank you. Okay. This is how it's used as a predicate nominative, okay? Our plan was, obviously was is a linking verb. What was our plan? To reach Albany before nightfall. That's a PN, okay? Equaling our plan. How it's used as an object of the preposition. He wanted nothing except to be the best. Except here is a preposition. Prepositional phrases need objects. To be the best is my infinitive phrase used as a noun in this case, okay? His desire to climb Mount Everest was realized. Desire is my subject, was realized is my verb. To climb Mount Everest is explaining what the desire is, therefore is in a positive. Okay? So basically what we were doing with gerund phrases, except now we're working with infinitives. Okay? So they can be an infinitive phrase. Just know that it consists of the infinitive plus any complements or modifiers, kind of like a gerund phrase, what we talked about earlier. But you're going to box the entire thing, underline your infinitive, your actual infinitive gerund, or verbal. Okay, let's look at exercise A. Underline each infinitive, draw a box around each infinitive phrase, then identify it if it's a subject, a DO, OP, PN, or AP. Okay, so go ahead and do page 137, exercise A. Go ahead and work on it. Underline your subject, or underline your infinitive, and then do your box the entire phrase, your infinitive phrase, whatever that may be. Okay, and then label if it's the subject, label if it's the direct object, predicate nominative, okay, what it's used as. Okay, let's do number 1. What did you underline? What did you box? And then what did you label its use as? Let's go with Elijah. What did you underline?
I underlined their sins, but
Not their sins. I'm looking for the word to plus a verb.
amen.
Good. To save would be my infinitive. That's what I would underline. What would I box, Maya? Okay, keep going. From their sins. That's what I would box. That's my entire infinitive phrase. To save men from their sins, what is it used as, Jesse? Not the predicate nominative. Okay, who can help him out? What's it used as? Andrew? The subject. Good. To save men from their sins was. Was is my verb. Who or what was my subject. To save men from their sins. Reason is actually my predicate nominative. Okay? It's equaling the subject. Number 2, the Trojans' rash decision to accept the wooden horse led to their defeat. What do I underline here? What's my infinitive, Lena? To accept. Awesome. What do I box, Derek? What's my entire phrase that I box? Good. To accept the wooden horse, what's it used as? Avery? A positive. Awesome. Explaining what the decision is. Number 3, seeing the stray dog's poor appearance, I could do nothing but feel sorry for him. Okay? In this case, it's following, or actually the 2 is understood here. Okay? So who kind of was confused on this one? Go ahead and raise your hand. Okay, so in this case, your 2 is understood. So listen to this. This is what it's supposed to say. Seeing the stray dog's poor appearance, I could do nothing but to feel sorry for him. Okay? That's why, no one talks like that. That's why the word to is understood. But my positive in this one is feel. Okay? X, feel. To feel. I would box to feel sorry for him. But in this case is used as a preposition. So if there's a preposition, what would this be, class? An OP. Okay? But in this case is used as the word accept. All right? And that is a preposition. And then number 4, King Alfred commanded his scribes to keep a record of important events. Okay? What would I underline here, Austin? Good. To keep. What would I box here? No, I'm looking to ask Ricky. What would I box here in this entire? What would my phrase be that I would box? Good. To keep a record of important events. What is this used as? Amethyst? Not an OP.
Then what is it? You freaking liar. It's not a deal. It's not a deal.
It is a DO. Okay, I understand. His scribes. I get it. Okay. But it's explaining. It's like that part of it is the subject of the DO. Okay. His scribes to keep a record of important events would all be boxed. That is my entire DO. Okay. Yes. Okay. Number 5. John Wesley's resolve to rise daily at 4 a.m. might be a good example for some of us. Okay. What do I box? Underline here, Adrian. Good. What do I box? What's my entire box, Isaac? To rise daily at 4 a.m. What is it used as, Doug? Shh, guys. Guys, shh. What is it used as? It is used as in a positive. Good. Okay. Tonight for homework, do page 138, number 6 through 10. Number 6 through 10. Okay? For homework, page 138, number 6 through 10.
11 through 18 extra credit?
No, because we're going to practice that in class. I mean, you can do it, but it won't be extra credit. Okay. Tonight, study your 6B words. So go ahead and pull that out really quickly. 6B on page number, Austin, please do not sigh like that. Page 45. 6B. Okay. Just study these commonly misspelled words. Okay. Commonly misspelled words. Not that you guys are going to misspell them. but they are common. Okay? So make sure that you study these, Derek, if you guarantee you're going to misspell them. Okay? Guys, stop talking. Guys, stop talking. Shh. Boys in the corner, stop talking. Okay, look at number 3. This is an exception to the rule. So notice how the E is dropped in acknowledgement. Okay, so you want to drop the E. There's no E in acknowledgement after the G. Number 10, also an exception to the rule. There is no E in judgment between the G and the M. You want to note those exceptions to the rule. Okay, and then the rule number 4 basically is saying which you would drop. Like if there's a silent E on the end, you would drop it or keep it. Okay, so with normal suffixes that begin with consonants, you would keep the E. So like M-E-N-T, basically. That's why it's an exception to the rule, because even though your suffix begins with a consonant, it's still dropped the E. Okay, so the number 3 and number 10 are exceptions to the rules. Same thing with number 4 and imaginary and imagination. You want to note those. Rule number 4, dropping the silent E or keeping it. Okay. Rule number 4 would be in adding a suffix to a word ending in silent E, retain the E if the suffix begins with a consonant, but drop the E if the suffix begins with a vowel. But notice all of those exceptions. Okay. So number 3 and number 10, make sure you're studying these. For homework, you were to study your synonyms. So 6B, there will be synonyms, and then of the vocabulary words on page number 46 and 47. So make sure you're studying that. Quiz 6B will be tomorrow, okay? You may pull out your literature books to study for a few minutes. Not today. It isn't Garrison.
It's like Gerasim or something. It's weird. It starts with a G.
It's Gerasim or something. Everyone should be looking at your book. No.
Guys, stop arguing. Kiss already.
Shh, guys, stop talking. Otherwise, I'm going to make you guys take the quiz without looking, or without reading. Shh, guys, Adrian, stop talking. 183 to 185 over the servant. Can you tell me what's on page 183 and 185? For those of you distant learning, we're looking over our story. just some.
Because they say that his name is Cheryl, the merchant, right? But then the one guy also calls him Igor Fiorder.
Yeah, Igor Dan those videos.
He does.
Igor Fiorder. So do these know that?
Just know what happens in the story. Maybe. It's just to show the unit that we're in with emotion. Yes. All right, guys, go ahead and take out a sheet of paper. Sheet of paper.
Wait, what?
Sheet of paper. Close your book. Put everything away.
We're doing this history style.
Okay, go ahead and take the quiz that will be on the screen as soon as it turns on. It's just 6 questions, okay? UVO, we're taking a quiz, so make sure you take this on a sheet of paper. You can write down the questions if that'll help you. And then turn this on a sheet of paper in by the end of today, okay?
Quietly. Okay, again, where's the remotes? As for some of you, or some of us, we already know that doesn't work. Trying to shove it in your backpack quickly does not work. You can ask Rick. All right, here we go. Welcome, distant learners. Make sure you throw your name in the chat. Okay, gentlemen. Okay, there has been trouble in these areas. Mrs. Coral wants me to move you. Okay, so this is your last chance. You three, don't look at me like that. You three talk. Isaac, you're on your phone sometimes. Just because I don't catch you, don't be on your phone. Okay, and yes, you three talk. Now, I'm not saying you talk the most, but you three do talk. Okay, you six, stop talking. Okay, not just right now, but we struggle talking during class. You six, all six of you. Okay, as I've already said, not just Mrs. Coral, but other teachers want some of you to be moved. So please be quiet, or else you will be. Sadly, that will hurt some other students as well. Okay, everyone else, be quiet. What?
How would that hurt other students?
What? I said other teachers.
Oh, I heard you.
Other teachers also want you moved.
No, you said that would affect other students.
Oh, because some other students maybe don't want you guys by them. So, yes, sir.
We don't want to switch to them. It's ours.
Not really. You should have already used it, so no. Sit down. You can wait till after class. All right, here we go. We are starting a new chapter. Okay, last chapter we talked about what? Shh. No, just the. Okay, we're talking about England. How it moved into. Shh. Okay, amethyst. Yes, those are all true. Gentlemen, this is what I'm talking about. No more talking. Okay, when I say gentlemen, it doesn't mean one person. Adrian and Rick. No more. Rick, turn around. Okay, you're one of the main ones that's going to be moved. Adrian, you are also going to be moved. Okay, you guys talk way too much. That's your last warning. So if you'd like to travel to games this week, okay, be quiet. Pay attention in class. Don't be on your phones. All right, yes, we talked about England. Okay, obviously towards the end of the chapter, we talked about the beginning of...
The new age.
Not quite. Okay, yes, we started mentioning the age of reason a little bit. Okay, but not quite. Age of industry. Okay, that's what we're going to be talking about this chapter, chapter 9 or 19. Shh. If you want to talk, raise your hand. I might call on you. Okay, but we see before this age of industry, we started talking about obviously the Constitutional Convention, the beginning of America, okay, which is going to bring us to this time of age of industry. Yes, our last note was George Washington. He became the leader because he was a general. Okay, but this brings us to the age of industry. Okay, also known as we're beginning our notes. Okay, any distant learners, if you like the notes, let me know. I can send them to you. Just message me or throw it in the chat. I'll send it to you as soon as I see it. Okay, but it leads us to this time of industrial revolution. Again, we're not doing a ton of notes today, so be quiet. Let's get through them. Okay, we're only doing a few, maybe 10, 15 minutes of notes. It's just an introduction of today's chapter, or our next chapter. Okay, so be quiet, get through it, then we can talk and work on our homework after. Okay, but we're talking about this industrial revolution, okay, which is a time of dramatic changes in agriculture, industry, and technology. Okay, as time moves, okay, we're progressing in different areas. We're learning, okay, as we do today. We learn and improve. Okay, they overcame and adapted. Okay, also known as Andrew said, the age of industry. Everyone good with this one? Everyone good with this note? Adrian, you wrote this note down? Remember, I could do notebook check anytime. Okay, age of industry. Okay, this is a period of great progress for Western civilization. Okay, which lasted from about 1760 to the 1900s. Okay, it brought about major advances in food production, healthcare, manufacturing, transportation, and communication, creating higher living standards for millions of people. We see that throughout that time. Okay, as we got automobiles. Okay, we're not talking about a few of them. Different agriculture, farming devices, equipment. Okay, different people that created that stuff. Happened under this age of industry or the Industrial Revolution. That is one of the things that happens under that time, or in this time, yes. Adrian, make sure your mask is on. Austin, Derek, make sure the mask is on. Not just on your chin, but covering your mouth at least. I know we hate them, but for school to be open, we do have to wear them. Okay, I hate them just as much. Imagine talking all class with them on. Very annoying. Okay, which is going to bring us to some new ways of farming, agriculture, as we see. Okay, the main way, or the first way we see, is called subsistence farming. Everyone good with this note? I know it's a little bit longer. Not subsistence. Subsistence. It's a little bit different. Subsistence is like an object. Subsistence, okay, is where something assists that type of farming.
So like fertilizer.
Because it's not just assisting, it's a type of it.
And it's fertilizer.
You'll see what it means. We have a note for it. Everyone good? All right, subsistence farming. Okay, it's where you grow just enough food to feed one's family. Okay, yes, it means with substance and assistance. Okay, it's where people engage in this form of farming. They have no provision against drought, disease, or other natural conditions and are doomed to a life of poverty. Okay, it's a hard way of living. Okay, this is obviously this type of farming. Okay, this area before we had everything we have today. Okay, imagine all the work that we do today, but with your hands, okay, and knees, and workers. Okay, a lot more work.
Some people who choose to farm.
It's true. It's true.
Just think about that. You're like, hey, what do you want to be? You could be a rocket scientist. You could literally be anything. A farmer.
I mean, to be honest, you can still make a lot of money farming. A lot of money. No, Rick, we're not going to talk about that right now. All right, which is going to bring us, everyone good with these ones? Shh, everyone good with this note? Trying to make sure everyone's done. Okay, we see a mastery of food supply. Okay, in this new farming ways we're going to talk about. Shh, quiet. Okay, the mastery of food supply is the most critical material factor in determining how far a nation may advance. Okay, you can only advance with the resources you have. If you don't have the resources, then you can't advance. Okay, so that's why in this time of industry, in this growth of this age of industry, farming or agriculture was probably the first thing that grew and one of the most important things that grew. Okay, for this nation, our new nation that was born, okay, obviously from the War of Independence, the Revolutionary War. Okay, we see for it to grow, we have to have the means for it to grow. Okay, because before this, a lot of our crops and things we got, okay, were from who? From England or Great Britain. Okay, we would supply them with things, they would supply us with things. Okay, but now we're on our own. Okay, we have to have a means of natural resources to provide for ourselves and for us to continue growing as it's a new free world and people want to come to it even today. Okay, we need to have the means of resources. Okay, we talked about the Great Awakening. Okay, so we're going to see also not only agricultural growth, okay, but we're also going to see some other growths during this time. Okay, because of the Wesleyan revival, work was given a new sense of nobility. Okay, Colossians 3:23 says this, "And whatsoever ye do, do it heartily, as to the Lord and unto men." Okay, basically saying, hey, okay, if you're working, work. Okay, work hard. Do your best. Just like the quote says, as you learn as a child, do your best and... No one knows the quote? Do your best and forget the rest. You guys have never heard that? Oh my goodness. I guess I'm old. Okay, do your best and forget the rest. Do your best and forget the rest. All right, so in whatever you did, you do your best, you put in your all. Okay, if you do that, then our system or our economy will grow and become better. We see that happening during this time. Okay, obviously under this Wesleyan revival, under this verse, under messages at this time, this is one thing that people preached. Hey, if you're in it, you're all in. Okay, you're doing it to the best of your ability. Okay, which brings us to this new work ethic. Okay, under this Wesleyan revival, this passage as well, okay, this idea of working to a new sense of nobility brought this new work ethic. Again, we only have like 2 more notes, and then we are done for today. Okay, so Monday, enjoy it. Okay, we do have homework, so we should be able to finish that in class. All right, but this brings us to, everyone good with this one? The Protestant work ethic. Okay, you probably have heard this before. Okay, but this idea, Derek, okay, of working with nobility, okay, brought this Protestant work ethic. Okay, what is that? It's on the screen. It is the way of life based on the biblical teachings that God expects all men to work and expects all men to work. I think I repeated that.
Yep.
It's okay. Just forget. It still says what I needed to say. And that all work is a noble duty to be performed toward God. Okay, God expects our best, whether you're a scientist, a farmer, a teacher, okay, an athlete, a businessman, a lawyer, and whatever you're doing, okay, He expects your best. Okay, this idea, okay, that was growing obviously in our new world under this revival, okay, that God expects your best in whatever you do, okay. The Bible says to give all glory unto God. Obviously, that's the blessings of what you reap. Okay, but we're supposed to work for it. Okay, things don't come easy. Okay, it doesn't just say when you're a Christian, He's just going to give you everything, does it? Does He say, hey, I give you everything? No, He says He gives you eternal life. Okay, but because of sin at the beginning of time, Adam and Eve, okay, it says that it's going to be hard. Okay, work's going to be hard. Okay, that birth would be hard. That's what the Bible tells us in the beginning in the book of Genesis. So we see this work ethic that everyone's supposed to work their hardest. Okay, throughout this time with this teachings, we're going to see some agricultural advancements. Okay, again, I told you that had to be the first thing that grew. This is our last note for today. Then we'll enjoy an easy day.
Last note, singular.
It's the last note. Okay, agricultural advancements, some things that they improved during this time. Okay, certainly at the beginning. First, we see the better use of land. Okay, obviously, okay, we've already talked about where did America begin? What side of the country? Where?
The rocky East Coast.
East Coast. Okay, as we ventured and as we grew population, we moved forward. We needed more land, more resources. Like we talked about, you need resources to improve and grow. Okay, so we see the better use of land, crop rotation, fertilization, okay, moving out more Midwest and West, finding different land for growing. Okay, not only finding better land and the use of their land, okay, better tools, better ways. Okay, we had some thinkers that created a system or a way to do it better. Okay, we see Jethro Tull's seed drill. Okay, drilling seeds into the ground rather than having to plant each one individually by hand. Okay, see John Deere's steel plow. See Cyrus McCormick's reaper, the thresher, and combine. Okay, these machines that we know today that have even been improved today, okay, than what they were way back then. Okay, so better use of land, better tools. Okay, with better tools, okay, you would need less people. Okay, so you had fewer farmers. We're feeding more people. Like I said, farming's actually can be a very good business. Shh. Raise your hand if you're talking. Okay, and last one, agriculture and industry paired to increase production. Okay, with all these new systems, we're going to talk about more as we go through this. Okay, they're improving, they're increasing their production rate because of the tools that are made, because of the people working behind it.
Is it true that the whole world's been discovered?
Is it true that the whole world has been discovered? Every inch of every piece of land? Probably not.
Okay, then I'm gonna go find something and then they made it.
All right, that is the end of the notes for today. Just an introduction. Again, if you want the notes, let me know. I can send those to you for homework.
There's homework?
Yes, there's homework. But guess what? I gave you 20 minutes to work on it, so you should be able to finish it right now. For homework. Shh, Adrian, quiet. Okay, we're doing page 280. Page 280. Okay, don't worry, I'm not making you cover all of it.
1 through 6 even.
Not even. Okay, we're doing page 280, section 2 review. Questions 1 through 4 all. 1 through 4 all. 1 through 4 all. Shouldn't be too hard. Okay, we're not messing around on our phones right now. Okay, I'm giving you extra time not to mess around. Okay, you're working on something. Page 280, section 2 review. Questions 1 through 4 all. Okay, we're going to talk about some more of those things tomorrow. Okay, make sure you do read the areas that it covers. Okay, I'm not going to make you read all of it as some teachers would, but read where the answers are. Okay, we can have a pop quiz at any time. Not saying we are going to, but we could. Okay, make sure you're filling in all your notes, as we could do a notebook check at any time as well. Okay, you guys did pretty good today. Make sure you're not on those phones unless you ask for permission. Certainly basketball players, because I expect the best out of you. Page 280, section 2 review, questions 1 through 4 all. Distant learners, let me know if you have any questions. Again, we will see you tomorrow. If you have any questions, just throw it in chat. There's still about 18 minutes left of class. I'll come back on the stream and answer your question if there are any. Let me know if there are.
All right, welcome to chemistry. Let's get started here.
Geometry.
Whatever.
You said chemistry. Just
Fine.
don't scare us like that.
Sorry. Welcome to geometry. My bad. I was just in chemistry. All right. And let's get started. Let's make sure we're not talking, because that would be rude, and I know you guys would never be like that. Quiet down. All right, real quick, couple things. Nope, put down your hand. Listen. I'm with him on this one. Anyway, okay. So here's the key things I need you guys to do today. First of all, turn in your homework. Turn in the quiz 20 if you have it done. Being passed out to you is quiz 21. Did you leave one on Amethyst desks? Okay. Desks? I can't talk. I also have no idea what just happened to my screen. There we go. So being passed out to you right now is quiz 21. Okay, quiz 21. You should have turned in quiz 20 already. If not, please do so at this time. And then you need to get out your homework so we can go through it. I need you to you're already late, so no, I don't want to hear it. Just sit down. I don't care. I didn't ask. All right. Good. All right, so here's the deal. I understand there was some problem with the homework, so we're going to go through it, okay? Seeing as your quiz is on this material, we need to be able to go through your homework. So the homework is a place for you guys to be able to learn, for you guys to be able to mess up. So you guys need to get it out so you guys can see what you did versus what you should have done. Make sure you're not talking over me because we have 5 proofs to get through, and I'm going to get through them all today. That's not my fault. All right, so exercises 2.34. Let's talk about this. You were told it had 4 steps in number 1. So very briefly, let's go through how to do this. So we're going to go ahead and create a diagram. And this diagram, we're told, is just a quadrilateral. So we want to avoid accidentally making any kind of regular shape. So we're going to do that. And then we're going to make this. And then we're going to do that. And then we're going to do switch over to dictionary somehow. I don't even know. Okay, obviously undo, because that's not what I meant to do. And there we go. All right. There's... Huh? Well, you should too, so I don't know what your problem is. Oh, the dictionary. Got it. Anyway. All right, so quiet down. This is our quadrilateral. Okay, it's not pretty. It's not supposed to be. It's meant to be a quadrilateral.
How many steps are in this?
4. Okay, and we are told, and sorry, I'm not going to spend time trying to get the corners correct. We're told that the lines joining the midpoints of the opposite sides in any quadrilateral bisect each other. Okay, so we're going to go through and create our lines to the midpoints. That's midpoint-ish. That's midpoint-ish. Yeah, I'm going with ish. I'm not taking time to actually measure. All right, so at this time, we're going to go through and create our labels. In my diagram, I'm going to use D, G, C. I'm doing A, B, C, D for the quadrilateral, and then I'm doing E, F, G, H for the other, but I have to do things in a certain number of text boxes because Google. When in doubt, just Google. Okay, not what I meant, but you know what? It works. We have H and F. Can we all just agree that those are... Oh, wait, no, I can do this. What? Give me a minute. I'm getting there. We need to finish our diagram. I knew how. Yeah, because I didn't care. I still don't. But I want it to be kind of close. All right, so save and close. No, I don't need it. It's not relevant. You can. Okay, just listen because I'm showing you guys the complete proof. Oh, nope, I needed one more. My bad. Oh well. I'll create it in a minute. Okay. So I'm given that I have quadrilateral ABCD with midpoints E, F, G, H as shown. By the way, my diagram is actually different from the books. I purposely did it that way to prove the point. Okay? So, that is our given. We have a quadrilateral. We have midpoints. Now, the name of this section is the use of auxiliary lines, so that means at some point you should expect to draw something. So I'm going to draw EF, FG, GH, and HE. 2 points determine line. Yep. So what I'm going to do is I'm going to come in here and edit my drawing. Okay? And all I'm doing is I'm connecting... What now? Why are you... What is happening? Okay, I'm trying to draw that to midpoint, but it ain't working, so... Oh, well. Oh, my goodness. Yeah. Well, the computer's not letting me. What do you want me to do? Exactly. I don't either. That's what I meant to do. Oh, my word. Can I just fix the stupid line? No, go to what I told you to do. What are you doing?
It's just hard when we have all these. It's hard to draw a diagram.
Well, you guys can do it on your paper if you need to.
Well, no, it's just, I feel like it's easier when to do exclusive auxiliary and F because they give you the diagram.
That's fair.
And like it's harder to do it when it's on homework. You have to make up your own diagram.
That's fair.
What's it?
Your point.
Oh yeah. That's why it was hard to do. I was like, I mean,
And again, I hear you, and it's fair, and I'm not necessarily committing to anything either way right now. Okay? Because I need to focus on getting this done.
oh yeah, sorry.
Okay, I don't know why it's not even... Well, then again, I didn't measure, so that would explain why I can't just copy-paste. All right, so we've drawn those lines. Save and close. Okay? So we have these lines drawn. Now, we have proven before that if we connect all the midpoints of a quadrilateral, it's a parallelogram. Whoops. That right there is why we write that at the end of the proven statement, so we know what in the world we're talking about. That's why we specify which exercise. Okay, so that's where we're pulling that from. Ignore the R. All right, so then finally...
Sorry, I'm writing some 10 minutes instead.
Okay, well, I'm going to keep going. All right, so because of that, EG and FH bisect each other. Okay? Now, you might be wondering how I'm jumping from 3 to 4, but let's talk about this. Okay? EFGH, our dotted lines, is a parallelogram. Okay? Or close enough to one in our diagram. Okay? Do you realize that by connecting all the midpoints and I had these lines connected, that I now have diagonals of the parallelogram?
Wait, what do you mean? Oh yeah.
Yeah, so the diagonals of a parallelogram bisect each other. It's something we've previously proven. So by just introducing a parallelogram, done. Yeah.
We have to prove it's a parallelogram. I know. We have to prove they're equal. We have to prove that they're parallel. We're going to figure out how to prove parallelogram.
You can't, because it's not.
You kept saying it was a parallelogram.
No. The lines I drew became a parallelogram
That's what I meant. We were trying to
due
figure out how to
to this. Yes. But now that that's done, then it's just you have diagonals.
Oh, it's because we didn't know we can just put that in space. We didn't know we can just jump from 2 to 3. We then had to put like stuff in between showing it. Yeah, the lines are parallel, therefore it's a parallelogram.
Yeah, that's why we have the proven statement section.
That's why we were struggling. I wasn't even looking at.
Guys, this is why I'm going over it. I didn't expect you guys to get it first try.
I know. I'm just kidding.
And I know that sounds like I wasn't setting you guys up to fail. It's just until you try, you don't know where you're struggling. Does that make sense?
Everywhere.
Okay. But you're starting to realize it, though.
That I'm struggling everywhere. I do the whole time.
Okay. So that's part of what this whole thing was about was, okay, what don't you know? Okay. Seriously, guys. Yeah, proven statements are part of your theorems and corollaries. It's the whole point of developing a series of logic like this. That's why I have you guys write them down. That's not me making you guys do extra writing because I like making you guys write things. Okay, as a matter of fact, I've tried to cut out as much as possible. But it's there so that way you guys can look back at it, much like your theorems and corollaries. All right. Oh, I should probably say each other. All right, so there's that. Number 5 got canceled, so I'm just going to erase that. Guys. Number 6, or sorry, no, we're on number 2. Number 2, your diagram is given in your book. I'm not going to recreate it here. Oh, rats. I actually do have to create it, yeah. So insert, drawing. I have to recreate their diagram. Ew. Okay, so you're given something along these lines. Lines. Excuse the dad jokes. Okay. Something along these lines. It wasn't a good joke. Okay, anyway. See, there's no such thing as a good pun. There's only puns that are so bad they become good. All right. All right, and then what we're going to do is we're going to draw in our proof another parallel line, but it needs to be like nudged up a little because I missed. Oh, seriously? Hey, there we go. Close enough. All right, so we're going to change our labeling just a little bit. And I do mean just a little bit. We have a... Stop that. I meant lowercase, so I typed lowercase, you stupid computer. What is this? Sorry, rip headphone users. All right. Okay, anyway. Sure. Either way. All right, and that's line B. If we wanted to name this line, we could name it C, but I don't care. It's not relevant. No. Nope. All right, so up here, oh, goodness, I hate text boxes so much. Stop fixing what I mean. All right, so this is, why? This is angle 1. Why are you like this? Why do you hate me? Because I needed to add that middle line. There we go, fine. There's angle 1. Down here is angle 2. Right? And then what this does is it splits angle 3. Now this diagram is not going to be completely accurate, because I don't know. I don't know how I'm doing it. So yes, I wanted QA. 3A and 3B. Okay. There. So we're splitting up angle 3 there. All right? And then this line was drawn. My bad. I should probably... There we go. Ta-da. Okay, cool. Good enough. Yes. I teach math. That's the same thing. All right. So there's our diagram. The only difference is I've added a line. Okay? Stop. So help me. I'm getting so annoyed with this computer right now. Yeah. Okay, statements, reasons. Number 1, we have our given. Okay? We have, literally, this is our entire given. You ready? Insert. Yep, that's it. That's all we got. So I'm going to draw a line through the vertex of angle 3 that is parallel to A. Real quick, the only reason there's a line in between is because there's a page break right here. So I'm not splitting this one up. That's exactly one parallel can be drawn through a given point to a given line. Okay, listen up. The official wording is through a given point, one and only one straight line can be drawn parallel to a given line, but like this wording's fine and it's shorter. All right, number 3. The new line is parallel to B also. Yeah. All right, a parallel to one or two parallel lines is parallel to the other line also. And silence. Thank you. Number 4. I am a little bit. Number 4, okay. Because of all that, angle 1 must equal angle 3A, hence why we named it that. And angle 2 equals angle 3B, okay. Because alternate interior angles are equal. Why are you like this, you stupid computer? No, it's just me. I'm struggling today. It's also been right-clicking on me all day when I haven't been. So, like, I'll just be scrolling and it'll click. And I'm like, stop it. Anyway. Now, number 5 is just a bit of housekeeping. Okay? Angle 3 equals angle 3A plus angle 3B. Because the whole equals sum of all parts. So, because that, the whole goal was to prove angle 1 plus angle 2 equals angle 3. Well, we've done that. Yep. By just substitution. Had all the pieces in 4 and 5, put them all together. All right, so that was the second one of your homework. We have to get going here because we have half of class left and we still have more than half your homework to go. So we're in 2.37. And if you guys remind me in future homework assignments, I can at least work with you to develop the diagrams. You just have to remind me because I will forget. All right, number 2 of 2.37. If you don't have everything written, it's on the Google Doc. Okay, number 2, you were told it was 9 steps. Let's go ahead and real fast create our diagram. Stop, you stupid, useless thing.
I'm sorry.
237, number 2, yes. All right, so we are told we have a parallelogram. So let's draw one. Yes. Because I don't remember. All right, and then I'm drawing okay, this diagram is not going to be super accurate because I don't have the time to make it that way. But basically what we're doing is we're creating this side, and we're copying its length this direction. It changes though, that's my problem. Okay, but it has to connect there though. Actually, wait, I can just right click. Maybe? No, not in this one. Cool, thanks. Well, normally you can just flip it, but alright, whatever. What am I doing? Oops, rip. I did. How? No. Okay, how do I rotate it though? Because the second I grab an endpoint, no, listen, the second I grab an endpoint, I change its length. It's not working on here. That's what I'm trying to tell you. Go. Anyway, so just assume those lengths are equal. That's fine. And then we're going to do the same thing over here. Okay, we're assuming that's equal to, oh here, I can just, nert, 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 nert. Whoops, rip. This is so sad. Stop. What is wrong with you, you stupid thing? I swear I know how to use a computer. Why are you like this? Just let me draw where my mouse is. Whatever, it's fine. All right, so there is my diagram. You be quiet over there. So we have D, F, C, and then we have A, E, B. Yeah, mine didn't have that. It's not letting me do it. I am aware that the option should exist. It does not. If it did, I would have used it, Gabby. Believe it or not, I actually do know how to use a computer. May not look like it at the moment. I just eyeballed it. It's fine. All right. It's fine. You got to remember, we're in class. We have very limited time left, and I want to get through all of them. So, oh goodness. All right, here we go. Okay, first of all is our given. So I have parallelogram ABCD. Stop. How did I even do that? I don't know. I legit don't know. Let me just. Okay. Shh. No, I don't. Anyway, moving on. They're killing that anyway. Anyway, we parallelogram ABCD with DE equal to DA and BF equal to BC. Because that, oh my word, is our given. Ladies, silence. Okay. Now, because I copied equal sides, that means I have equal angles. So angle A equals angle AED, and angle C equals angle CFB. Because angles opposite equal sides in a triangle are equal. Now, number 3. Why not? There's no confusion. That's the only thing, is if there's confusion, then you can't. But if it's just a standalone angle, you can. It's a shorthand. Anyway, angle A must equal angle C. Opposite angles of a parallelogram are equal. So then, by substitution, angle AED is equal to angle CFB, which means then I have created yet another parallelogram. Oh, nope, just kidding. Rip, I read that wrong. AB is parallel to DC, by definition of parallelogram. I hate that word. It's so hard to type. All right. Yes, that word trips me up every time. Yes. Number 6. Now, I have two parallel lines cut by a transversal. Which two are we talking about? AB is parallel to DC. So AED is equal to FDE. Okay, so using DE as our transversal here, okay, I can state that angle AED is equal to angle FED. Sorry, nope, DE. Because when two parallel lines are cut by a transversal, the alternate interior so much formed are equal. In years past when I've done this, I've done it in a program that reads LaTeX, but the problem is then I can't share it with you guys as easy. So like I'm using Google Docs, but like all the shortcuts I'm used to using don't work. So part of my frustration. Anyway, so when two parallel lines are cut by transversal, the alternate interior angles formed are equal. Then, well, I've established that AED equals CFD. I've established that AED equals FDE. So then, whoops, I can establish that angle CFB equals angle FDE by substitution. Substitution. There we go. What is wrong with me? The proof is not the hard part today. Okay, anyway.
You know what's funny? I'm writing this all down by hand. That's what's funny.
Number 8. Yes, but at least then you can use shortcuts. Number 8, DE is parallel to FB because two straight lines cut by a transversal to form equal corresponding angles are equal. No, parallel. I mean, fair enough. So then that means we have made a new parallelogram. Yes. Okay, there you go. By definition, parallelogram, we have one. All right, next one up, we had number 3. Oh my goodness. Why does this class fly?
It's already 11:30. Are you kidding?
It's take home. Your quiz is take home. It's open book. You have 2 proofs.
How many steps are there for the quiz?
I'll go through that after this problem. Okay. All right, I have a triangle. Am I told it's isosceles? Yes. Lines drawn from the base of... Nope, hold on. Okay, I cannot multitask. You be quiet over there. Okay, from the midpoints of the base of an isosceles triangle to the midpoints of the legs with form a rhombus or a square. Okay, so when is it a rhombus, when is it a square? So let me go ahead and create the connecting lines. Guys. Stop it. You should be. All right, we're dealing with triangle ABC. I'm going to label this midpoint as D. guys? All right, I'm going to label these as points E and F. Yeah, because it's triangle ABC. I just haven't gotten that far yet. We're on number 3, dude. Yeah, that might help. I don't know what to tell you there, man. Yeah.
What's the most demands you've ever given me?
Hey, guys. Let's focus on the lesson. Thanks. Taken. All right. Anyway, this one only has 6. All right, here we go. I don't know. Don't care. Number 1, I have isosceles triangle. Yes. Triangle ABC. So help me, Douglas. Focus, please. With AC equals BC. And then D, E, F are midpoints of AB, BC, and AC. Siri, no one asked you.
I didn't ask.
He's like, I didn't quite hear you.
You weren't supposed to. Okay, anyway. So they are the midpoints respectively as we go around. Now, we're told to prove that this shape becomes a... means in order, so D is the midpoint of AB. Yeah. All right, so real quick, we're proving DECF, either a rhombus or a square. We're to specify which is which. Keep in mind that a square is a rhombus, so let's go for rhombus first. And then we'll add this special condition for square. What? DECF. This is a rhombus. A diamond is a rhombus. There's no difference between the shapes. I actually really hate in kindergarten that they teach it as a separate shape. We're moving on. Because we do. Number 2. Guys, I have no time. Pay attention. 2. DE is parallel to AC. Oh, so help me. AC. DF is parallel. Do you think you're being funny right now?
Why is Siri going off?
Oh, my word.
What?
Is that mine? Siri, go away.
She answered the question.
Quiet. Oh, okay. Number 2. DE is parallel to AC. DF is parallel to BC. Okay. So we have the line joining the midpoints of 2 sides of a triangle is parallel to the third side. Seriously, y'all have this quiz is not going to get an extension. I'm not going to do this again tomorrow. I'm trying to help you here. Stop being a goofball for 2 minutes and pay attention like your life matters here. I was trying to say like your life depends on it, but then like my brain switched halfway through. I don't know what happened there. Okay? You know what I mean. Number 3. Oh yeah, that could be my problem. All right. DECF is a parallelogram. Can we agree on that? Cool, because it's by definition. We have parallel sides. Done. Number 4. Then if I have a parallelogram, that means DE equals half of AC and DF is equal to, oh my goodness, why? I hate the fact that cursors disappear when you're typing.
Is there a reason that you said DECF instead of saying it in order? Instead of saying DECF?
Because you always go around the thing.
Okay.
So DECF. You always go around in order. As far as why I started at D, because I did. and because the book did. All right, so DF is also equal to half of BC because a line that joins the midpoints of two sides of a triangle is equal to half the third side. Well, because I have halves of equals, then they are equal, so that means DE is equal to DF, because literally halves of equals are equal. That's also the division axiom, but if we can use the exact wording, why not? Anyway, so then that makes it a rhombus because I have equal sides. Actually, more specifically, I have two equal sides in a row. It's a parallelogram with two adjacent equal sides. So as long as I have two adjacent equal sides, it's a rhombus. I don't have to prove all the sides equal. I only have to prove in order. So this is a rhombus by definition of rhombus. Now, we could expand this and try to figure out when it's a square. The answer is this is a square if C is a right angle.
I'm sorry, what? Dude, I actually thought that we had to do a whole other thing today.
No, because it's not asking us to prove it being a square. It's asking us when would it be a square.
Or that angle.
Haha. Anyway, because a parallelogram with a right angle is a rectangle, if it's a rectangle rhombus, it's a square. So we have it's a parallelogram, so if C were to be a right angle, then it would be a square. Okay? So it's always a rhombus. It can be a square. I do not have time to go through number 19 because there's literally less than 2 minutes of class left. Okay, so that will have to wait until tomorrow. So we'll finish that one up real fast in the morning, or in the beginning of tomorrow's class before starting 3.1. You guys do have that quiz tonight. Yes, that is due tomorrow. That is your only homework, though. Quiz 20 was due today. We will finish off this homework lesson tomorrow. Please remind me because I may forget and start trying to jump into 3.1. And before I go, very quickly, quiz 21. Your first proof the book does in 7 steps. The second proof is in 6.
Hey, this is the math section of the homework. Wait, how many were in the first one? Is that okay? Did I
Yeah,
put it in?
it's fine.
I didn't label it, sorry.
Okay. What?
How many were in the first one? 7, 6.
7, then 6. Okay? So there's 7 steps in the first proof. There's 6 steps in the second on that quiz. Distance learners, the quiz is on Google Classroom. Past that, I will see you all tomorrow. Yeah, did you not get one? You sure? Gabby?
you. Okay, this is where we left off on Friday. We're page 5 of your notes. Gentlemen. Hey, time to be quiet. Austin, that's enough. Okay. Today we're starting off with the charge carriers. Please don't start. We're just going to finish lesson 70 or whatever lesson this is. 88. Okay. Okay. So neutral atoms. A neutral atom contains an equal number of negative electrons and positive protons. Okay? When they have equal, they make them with no charge, or it makes them with no charge. So a neutral atom can gain or it can lose electrons. And thus, when it does that, it becomes what they call an ion. An ion is an atom or group of atoms that has an electrical charge. So until it gains or loses, it's just a neutral atom. The negative ions are called anions, and the positive ions are called cations. Yes, sir. If what hit? Okay. Ask your question. Okay. What if? What do you have? I mean, there's more to your question, isn't there? Then it's either going to lose or it's going to gain some electrons. Okay. Okay. And it's either going to become an anion or a cation. Okay. Yes, sir. Onions have layers. So do atoms with their electron shells. Okay. Okay. Now, the flow of charge from one place to another is what they call the current. Okay. So, some currents in gases. A gas such as air always contains small amounts of ions and free electrons. Air can conduct a current, but generally is not a good conductor of electricity. Why not? Why is air not a good conductor of electricity? Okay. Okay. There's too much gapping between the molecules. Okay, things are just spread out too far, so nothing's sticky. Okay, in the air, it's just going right through it. So, some examples of currents in gases. A positively charged wire and a negatively charged wire are held apart in the air. If the charge difference is not very great, each wire slowly discharges. The electrons from the negative wire leak away to the positive ion, while electrons in the air neutralize atoms in the positive wire. Okay? So if they're not close enough, the electrons are moving into the air, or I should say the ions are moving into the air, and no, it'd be electrons because they're not ions until they gain or lose. And because of what we just said, of why air is not a good conductor, then they have a chance to escape the process. And in escaping the process, they don't do electricity, it's just cause, by combining or meeting up. Now some do, just because there's enough of a jump from one to the other, but it's like jumping over a ravine, small enough to be able to get over, okay? A ravine. Not talking about bushes, talking about a ravine. That's basically a big ditch in a road, okay? So, you take a run at it, and you jump, and if you don't make it, you're going to go down into the ravine. That's what happens here, is that the electrons are jumping from one to another, but some of them are making it, some of them are not, and they float away into the space. Energy, keep in mind, never ceases though, it just changes form. If the charge difference is great enough, a chain reaction begins. Ions and free electrons in the air accelerate to high speed in opposite directions, striking neutral atoms along the way and ionizing them also. Okay? So it's a mad rush out there, mad mob rush, if you want to call it. The new ions and free electrons join the rush. They bombard atoms, not yet ionized, forming the plasma. Okay? So that's what's happening with this spectroscope. You get the plasma coming out to the edge. It's the edge and the inside that's connecting to create its plasma. Liquids and solutions, so currents and liquids. Liquids and solutions conduct a current through the movement of ions. Electrolytes readily conduct electricity because the ions can move freely. So if oppositely charged wires are placed in an electrolyte, cations will move toward the negative charged wire, and anions will move towards the positively charged. Okay? Because anions are the positive, cations are the negative. Yeah, that's basically what we're talking about, just in a different form. Yeah. Okay. Liquids that do not contain the free ions typically do not conduct electricity. They are just strung out there as neutrals. Okay? Ready to be picked up. Okay? They're just out there ready to be picked up for an electric date. Atoms of a solid energy. Atoms of a solid are in fixed positions. The atom has acquired a charge by the gain or the loss, positive charge, negative charge, of electrons, and it's not free to move in response to the electric force. Okay? So, a charge can flow only through the movements of electrons from one atom to another. Okay? So you got to keep that in mind, that it only can move. It just can't jump and move itself. Electroscopes. This is basically just a simple device that uses the laws of electrostatics to detect small electrical charges. William Gilbert is credited with the invention of the electroscope. His electroscope, called versorium, meaning to run around, is a compass-like device consisting of a small, lightweight metal arrow free to turn horizontally. Okay? If the versorium turned toward an object brought near it, the object was charged. Okay? So this is how he determined it. If the versorium did not turn, then the object that was put there was an uncharged object. Okay? And so that's his experiment, to see what was charged, what was not. So maybe he took a pencil, took a piece of lead, they didn't have paper clips back then, so they took a little wire, okay, and put it next to the object to see what could turn the little arrows. A modern electroscope consists of a pair of delicate metal foil leaves, suspended from a metal rod and enclosed in a glass container to isolate them from the dust and air currents. Okay? And that's important, that it's enclosed so it's not going to have the interference of a breeze or anything else that's going to cause. The thinner the leaves, the more sensitive the electroscope will be. So the most sensitive electroscopes have leaves of finely beaten gold. Okay? How many have ever seen that gold that they put at a bakery on cupcakes or whatever? Okay? That's kind of what we're talking about. Well, not that gold. That's a plating of gold. But this is just very thin sheets, leaves of gold that they're made out of. When an electroscope is uncharged, its foil leaves hang down, nearly touching each other. When a charged object is brought near the knob at the top of the metal rod, electrons flow through the rod to give the knob and the foil leaves an induced electrical charge. Okay? So, just the electrical charge. Okay? I'm just imitating the leaf. Okay? The greater the charge on the leaves, the more the leaves spread apart. Okay? Okay? So, no one should miss that question when it comes up. The one thing that is needed to know when an object is unknown charge, gentlemen, of an unknown charge is brought near the electroscope is the initial charge of the electroscope. Okay? You cannot forget let me put it in a geometric term, what the given term is. Okay? What the given information is. What's the given information? Shh. What's the given information here? What the original charge of the electroscope is. Okay? So you got to know those things. Okay? DLs, short lesson today because I just wanted to end it on this today. 9.2 is your homework. Reading pages 221 to 223. And tomorrow we have quiz 18. It is not open book. Okay? So I'm going to cut you off now. Let you have time to get 9.2 done. And those in the classroom, same thing. You may work on that as of now, Ricky. DLs, we all say goodbye. So long, farewell, Alvida, say good. There you go. They're kind of slow, but you know, they get onto it. Bye, guys.
All right, welcome to Algebra 1. Let's get started. We are on 5.3, page 163, please. Page 163. We are on 5.3 with page 163. Again, this group, you are silent or out. I'm not going to, silent does not mean whisper. All right, you guys over here, and you. Hi. All right, I keep forgetting you're on the side. All right, you need to pay attention to today because you will get lost if you don't. Okay? Thursday, we left off with dealing with solving by substitution. The problem, as you may have gathered from that, is that can get quite tedious very quickly, okay? Because you have to solve one equation completely for a variable, plug it into the other equation, solve that down for the other variable, then plug into the first one. It can get pretty tedious. Now, it's doable, and it always works, and that's the key. Substitution is your default setting. Does that make sense? If you don't see any of the shortcuts, that will always work. However, today I'm going to teach you guys a shortcut, okay, of sorts. Yes? 163. All right, so we call this method the analytical method or the elimination method. Excuse me, it's also called the addition method. So a lot of times I'll say elimination or addition. Most of the time I'll probably say addition, but that's not because of anything other than that's the term I learned with it. Okay? So that's what we're going to do here. So let's say I had the system of equations of 2x minus 3y is equal to 12 and negative 2x minus 2y is equal to 3. Well, there's a basic principle that as long as I add equals to equals, everything remains equal, right? Okay? That's a basic axiom of mathematics. Axiom just means something we assume true at the beginning without proof. In other words, essentially we define it to happen. Okay? Don't worry about it. I use fancy words. Chill. All right, so real quick, that means that I could just add the two equations together because they're equals of equals. So I'm going to go through and add the two equations together. I'm just allowed to do this. Don't worry about the why if you don't get it. Okay? Just know that I can. Because I said so. Okay, moving on. All right. Watch me. All right, 2x minus 2x is what? 0x, so I don't have to write anything because 0 times anything is 0. Negative 3y minus 2y is negative 5y. And 12 plus 3 is 15. Now, I can real fast solve for y, divide both sides by negative 5. And y is equal to negative 3. Yeah, don't forget your negatives. They matter. Yeah. Then I can pick either equation. Doesn't matter. I tend to grab the top one, but do whatever one you want. But just in my examples, you're going to notice I tend to grab the top one. That I have no idea why, other than I do. We'll get there. Anyway, so we get 2x minus 3 times negative 3 is equal to 12. So 2x plus 9 equals 12. We subtract 9 from both sides because, you know, that's what we do. So then we get, did I mess something up? No, that's right. 2x is equal to 3, so x is equal to 3 over 2, or 1.5. Okay? And since most of the time, or a lot of times we'll want to end up graphing, we'll say 1 and 1/2 and negative 3. Adrian, I'm not going to keep competing with you. Make sure you're quiet. All right, negative 1 and 1, or sorry, 1 and 1/2, negative 3 is our answer. Do you see how much faster that is? Okay. Now, it can be faster, and here's the catch.
No way.
What they said. I was getting there. You all just beat me to it. Silence. Okay. Okay. All y'all be quiet. Done. Don't make me go southern. All right. Now, moving on. Just be quiet. How hard is that? How hard is that concept? Stop talking. Okay. Now, the key thing I want to point out here is that it can be faster. And I know that's kind of a duh statement because I just proved it can be. It's not always faster. And that's the catch. If it's not something where you can quickly get the numbers to match, or they already match, you're better off solving by substitution. There are plenty of times where it's just faster just to use substitution in the first place. Okay? So you have to look at your set of equations, see does this lend itself to elimination? Okay? You don't just always want to use elimination. You don't want to always use substitution. You want to use whichever one fits best, although I have a general rule for this. Okay? The best one is whichever one you understand the best. Okay? And my other general rule is that faster math is only faster if you see it. Okay? And that's something that a lot of math teachers will get hung up on. Of like, well, you didn't do it the fastest possible way. Did they get to the answer? Yes. Okay, then they got there their fastest way because they started working instead of analyzing it for 20 minutes. All right, anyway, so I'm providing you with different options, different tools. Again, we're still doing the same thing. We're still finding the point where the two lines meet, right? Okay, this is just option number 3. Okay, options 2 and 3 are preferred. Option 3 is the fastest with an asterisk. Okay, moving on. Example A. Guys, shh. Example A. Rick, zip it or see me after class. For the 3rd time, be quiet. Do I make myself abundantly clear? So zip your lips. Maybe open your textbook to page 164 and open your ears instead of your mouth. Thank you. Example A. X, no, not every time I stop to breathe should there be people talking. Every time I pause, even for a second, to even look over at my textbook, someone starts. It ends now. Because it's always one of you 3. So you 3 fix it. Don't act shocked. You have to know I'm always telling you to be quiet, Austin. We have x plus y equals 4. We have x minus y equals 3. Does this lend itself to elimination, yes or no? Yes, because the y's are already the same number with opposite signs. They're going to completely go away. Okay, so x plus x is 2x. Y plus negative y is 0. So we don't have to do anything. 4 plus 3 is 7. Okay, this is faster if you know how to actually add sign numbers. Okay, now we need to divide both sides by 2. And we get x is equal to 7 over 2, or 3.5. Okay. Now, yeah, I do. But for graphing, they're easier. And typically, we're dealing with the point we're going to end up graphing. Okay, moving on. Now, I'm going to use 7 over 2 in my equation because it's easier for the math. But I'm going to keep the mixed number for my final answer. Does that make sense? Okay. So that's the idea. Past that, I'm just picking one. It doesn't matter. Again, I'm going to just grab the top because it's something to grab. So y equals negative x plus 4. So y equals negative. Actually, no, I'm going to grab 3 1/2 because this makes this real easy. Plus 4. What's 4 minus 3.5? Half. It's 1/2. So then that means my final answer is 3.5 and 1/2. For what? Okay. Now, moving on here. Okay, let's look at example B. Now, sometimes it's not handed to you on a silver platter, but it's really easy to get to. Okay? So, like shown in example B. So let's be paying attention here. And let's get started. Okay. What are you doing? Okay. 3x plus 2y equals negative 4. 2x plus 3y equals 5. Okay. Moving on here. Notice, it's not going to really work out well. Okay? So, instead, I'm going to take, which one do you guys want to get rid of, x or y? I don't care. X? Okay, so let's get rid of x. So, if I multiply the top by 2, okay, do you see how I'm going to get 6x plus 4y equals negative 8? Because 3x times 2. Everything times 2. Everything times 2. For the bottom equation, I'm going to take everything times negative 3. Why would I introduce a negative? No, I'm asking, stop freaking out. Just think it through. Why would I want to introduce a negative?
So you have a negative problem to solve. So they're like,
But you got negative 8.
As a negative.
Please.
mom.
What the heck?
Guys. Thank you. Guys, I'm trying to add up to 0. Do you only wait? Because otherwise it doesn't go away. If I just add it right now, I get 3 plus 2. That's 5. That's not 0. Because one of them has to go away. That's the whole point of what we're doing. Adrian, wait your turn. Huh? Because that's what we're doing. Look. Example A only works because y went away. The sample I showed you only works because x went away. One of them has to leave. Okay, so that's why I'm trying to get a negative. Adrian.
Why is 2 in the top? Like, why not?
Because right here, right here. Okay? What's 3 times 2? 6. That's not how you find the least common denominator, but you're essentially finding a least common denominator. I know it's not fractions. Least common multiple. That's the word I want. Yeah, you have to multiply the whole equation. You can't just multiply one piece. Because what you do to one side, you have to do the other. I can't just do part of a side. Like math, its existence. Okay, moving on. Nope, we're done. We're done. Stop talking. So we're going to have negative 6x because negative 3 times 2x is negative 6x. Negative 3 times 3 is negative 9. And negative 3 times 5 is negative 15. We all good so far? Okay? I purposely introduced a negative so the x's would go away. Were you listening? Because if you're listening, I explain what I'm doing at every step. Negative 3 times 3y is negative 9y. I actually straight up said that sentence. So eyes on the screen. So eyes on the screen. If your eyes are on the screen while I'm doing the math makes more sense. Nah, you're done. Okay. So first thing I'm going to do is I'm going to go through silence. I'm going to go through and add. 6x minus 6x is 0, so we don't have to do anything. 4y minus 9y is? Y'all kill my soul every time you forget the negative. It's negative 5y. Yeah, you're the only one. Negative 5y is equal to, okay, negative 8 plus negative 15 is? Negative 23, thank you. Oh my goodness. No, 4y plus negative 9y. Not minus. We're not subtracting. We're adding. We're adding. That's why I introduced negatives.
You like that one when it's like WC.
Okay. Silence. Again, if you all stop talking, y'all might learn. Okay. Divide both sides by 5. Y is equal to then negative 4 3/5. Because 5 goes into 20 4 times. You have a remainder of 3. That becomes your new numerator. Just because I know that's coming. All right. Oh, my word.
Oh, Adrian.
No, the answer. Why negative 20 over 5?
It's not.
It's right there.
Hey, Adrian. Hey, Adrian. Make sure you're looking at Y. I let you guys pick, so I didn't follow the book. Clearly. Okay, moving on. Using the bottom equation because it's where I have room to work. We have 2x then plus 3 times what I found for y. Nope, I'm putting in the... rip. I messed up. I was too busy astounded by y'all. Negative over negative is positive. Okay. Anyway, so I found that this is 23 over 5. This equals 5. Let's go through and solve. First of all, I need to distribute that 3. So we get 69 over 5 equals 5. We're going to subtract 69 over 5 from both sides. Real quick. 5 is equal to 25 over 5. Yes? That's where that's coming from. I'm replacing the 5. Okay. Now, then 2x, sit down. Sit. Sit. Isaac, turn off the light, please. There, now you can see. Okay, 2x equals, then it's 25 minus 69 all over 5, so I'm still going to have a 5 here. I'll deal with that in a second. Excuse me. Oh. Okay. So off to the side, very quickly, I'm just going to subtract 25 from 69 because that's what we do. So we get, knock it off. You're not clever, you're not funny. I don't care who it was. So we get 44 over 5. Okay, divide both sides by 2. So this would become 44 over 10, or I could just divide the numerator by 2 anyway, so I don't have to cancel. So we get 2 goes into 44. So help me, one of these days I'll be able to do things. We find out that x is equal to 22 over 5, whichever way you slice that one. Okay, which by the way is equal to 4 2/5. So my final answer then is 4 2/5 and 4 3/5. As you can tell, graphing that would be tons of fun. Oh, rip. How did I mess that up again? Negative, guys. It's negative. The negative 69 is bigger than 25. X should be negative. Ah, come on. Okay, so I should have negative. Guys, see me after class at this point. Okay, we have a negative here, we have a negative here, and a negative here. No, you're going to be quiet, or you're going to go to the office. I'm done. Okay, is that clear? Make sense? Okay, if I wasn't fighting you guys talking the whole time, I might actually be able to focus on this. Okay? That's what we're doing. Okay? Keep track of your negatives. They're slippery little things. Okay. Example C. Let's stop talking. We are given 3y equals 18 minus x. We have 7x is equal to 11 plus 2y. Is this the form we've been working with? Ow. No, I've been dealing with x, y equals constant. Okay? So let's get them in order first before we can do anything else. Okay? So, the top equation becomes x plus 3y equals 18. I just added x to both sides. No. Then we have 7x minus 2y, because we have to subtract 2y from both sides. We have to undo it. Equals 11. Okay, now at this point, we could really go either way. Now the book gets rid of x, and here's why the book is getting rid of x. Okay, I want you guys to look at your equations. Notice that there's nothing in front of x. It's going to make it real easy to match. Does that make sense? Okay, so that means all I'm going to have to do is multiply the top equation by 7, and I'm done. It'll match. If I try to eliminate y, I've got to multiply both equations by something. Does that make sense? So that's why we're going to do that. So off to the side over here, let's go and multiply the top equation by 7. We get 7x plus 21y is equal to 18 times 7, which is... Oh, you know what? We should also introduce a negative. Well, the 7 down in the green one is positive. So we should have negative 7x minus 21y is equal to 18 times 7. I don't know. It's 126. So negative 126. I didn't do that in my head. I looked in the book. Chill. Whoops. Why am I in green? And negative 7 goes to every piece. 7 times 3 is 21. Okay. Now let's go through and eliminate x. So we get negative 23y is equal to negative 115. Really? Do you know? What did I mess up? Equals 11. Okay. Anyway. So now we're going to remove negative 23 from both sides by division. So then y is equal to positive now because we have negative over negative. And that becomes a 5. It does divide evenly. You would do that off to the side somewhere. Okay. Okay. Now I pick an equation. Typically, what I'll do is I'll grab whichever one was simpler. So I have x plus 3 times y is equal to 18. Notice I grabbed the original instead of the one I multiplied. Makes life a lot easier. All right, so we get x plus 15 equals 18, and x is equal to 18 minus 15, which is simply 3. So my final solution is 3, 5. Cool? You guys get it? Okay. I'm going to upload it to Google Classroom. No. Okay. Anyway, I'll upload these to Google Classroom so you guys can review them further. Your homework tonight is practice 5.3 blue. Let me be extra clear about your homework, and then I'll export these and put them on Google Classroom. But let me get that up there first. What is going... I used the wrong keyboard shortcut. I'm still adjusting to Mac. Anyway. So, let me put it this way. 5.3 practice blue is your homework tonight. That is due tomorrow. If you're on the team, it better be turned in on Google Classroom or on this desk before you leave. Okay? Review of solving systems is due Wednesday. We already had Friday as a work day for it. You will have tomorrow as a work day for it. Those of you on the team, should be working on it. Anyway, quiz 16 will be on Wednesday. It's over 5.2 and 5.3. And quiz 17 will be on Friday over 5.3 and 5.4. I'll teach 5.4 on Thursday. Okay, just so we all know what's happening when. Yes. That's unfortunate. Okay. Guys, we're done. Okay? So, stop talking, get to work on 5.3 blue. I'm uploading the slides now. Guys, everyone, no, listen. If you have a question, you can raise your hand and wait for me to call on you. Austin. Yeah, that's fine. Yes. Sure, that's what I want to do. That makes sense. All right, distance learners, I'll see you guys later.